All right, hello everybody. Today is the last new thing for the unit. And we're just gonna put everything together. That's what today is, putting it all together. So we're gonna fully factor stuff. We're gonna solve, find out what x equals when y is 0, and then sketch the function. Everything we've been doing. Okay, so we talked about sketch drawing last time. That's what we're going to be doing at the very end, but before we do that, we need to factor the function. So we're going to factor fully first. We're going to solve. This is finding the roots. And then we're going to sketch. And so that involves in behavior and multiplicity, possibly. Okay. So that's what we're doing. We're going to start with a easier one first. Easier. Sketch f of x equals x cubed minus 5x squared minus 2x plus 24. And let me make sure I got all my coefficients correct. Cool. Plus 24 at the end. So I have my in behavior chart right here. In behavior chart. We're going to use this at the end when we sketch. And if you need it, you could use your notes on factoring. Okay. This can't be factored by grouping, right? And I'm noticing that because if I took x squared out of this and I took a 2 out of this, I don't get x minus 5 both places. So it's not going to factor by grouping. There's not a greatest common factor here. So we need to use the rational root theorem, the thing that always works. So we do p over q, could be x, and these are going to be all of our factors. Yeah. So all of our factors of 24 divided by all of our factors of 1. And we're going to go lowest to highest. So 1 plus or minus 2. These are all divided by 1 since this is just 1, so I'm not writing the division, but you know, they're all over 1. 2, we can divide 24 by 3. Plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. We're probably not going to get to here. We might get to here. Or it might be 1, but it's probably not 24. It's probably not 12. So now I just check these using my synthetic division. So we'll start with 1. So 1, 2, 1, minus 5, minus 2, 24. So we're going to add down, multiply, add down, multiply, add down, multiply, add down. And we want to get 0. That's our goal. So 1 times 1 makes a 1. Add down, we get minus 4 times 1, negative 6. 18 does not equal 0. So it's not 1. My guess is that it's also not negative 1, but we'll check anyway. 1, negative 5, negative 2, 24. Down, multiply, add down, we get Negative 6 times negative 1 is positive 6. Positive 4, negative 4, we get 20. That does not equal 0. So it's not 1, it's not negative 1. So then we just check 2. Add down, and then we'll multiply. So 1, 2, negative 3, times 2 is negative 6, times 2, or plus 2, negative 8, multiply negative 16, and that is positive 8. That does not equal 0. So then we check negative 2. Same thing, add down 1, multiply here, we get negative 2, this makes it negative 7, multiply, we get 14, that makes it 12, multiply, we get negative 24, and we do get 0. So that means that negative 2 is one of the factors, and when we factor out negative 2, we're really saying, okay, negative 2 is what x equals, and so the binomial that comes out is x plus 2. It's the opposite, because if I put in negative 2 into here, I get 0 at the end. And then what we're left with is 1x squared minus a 7x plus a 12. So that is my factored function with x plus 2 being factored out. It's plus 2 because this is the opposite of this. If I put in negative 2 into here, then I get a 0. So we're not done factoring. We need to factor this thing. We can use our previous method before and like just use synthetic division to check the next numbers. Don't check negative 1 and 1 again. Those didn't work the first time. They're not going to work again. Just go on to 3 and 4. Or you can use the Xbox method. So A is 1, B is negative 7, C is 12. We get numbers that multiply to make 12, add to make negative 7 are going to be negative 3 and negative 4. Both negative so that they add up to be 7 and multiply to make a positive. And so x plus 2 times x minus 3 times x minus 4. We use these numbers. You could use the box, but you don't need to because a is 1. Okay. So this is fully factored now. Which means we need to solve. In other words, what values of x make this equal 0? Well, it's actually pretty easy. We kind of found some of them already. Put a negative 2 in here. Put a 3 in there. And put a 4 in there. And so those are my 3 solutions. And now we can start sketching. Thought I was going to have to do this on another page. So we got negative 2, we got 3 and 4. So 1, 2, 3, 4, and negative 2. Now remember, we don't care about how high the valleys and peaks go between these points. We just care which direction does the graph move through these. We don't have a multiplicity. None of these are squared or duplicates. And so the graph is going to cross through each of these each time. We just need to figure out what direction is the graph going. So we use our in behavior chart, and I'm going to refer back to the beginning. This was our original function, x cubed minus 5x squared minus 2x plus 24. We only care about this. This is a positive leading coefficient and an odd degree. So odd degree, positive leading coefficient means it's going to go up to the right and down to the left. Up to the right and down to the left. So up this way and down this way. And then the graph has to go through the coordinates. And so no bouncing, like this isn't going to go back up right here. It's going to go through because our fully factored form had no duplicates, no multiplicity, no double roots. So then it needs to curve back around and go through this point, and then curve back around and go through this point. Now, how high this is, how high you draw this piece, how high you draw this piece, don't really matter. We just care, okay, the ends are going in the right directions, and it's crossing through all of these points correctly, or bouncing correctly. In this case, none of them bounce. So this is our end sketch. Now the scale here is probably way off, which is why I didn't even draw the y-axis scale, but it doesn't matter. All right, so we're just taking all of our pieces and putting them together. Fully factor the function, find all the solutions, and then use the end behavior to draw the curve through the solution points. Okay. Let me actually look at the homework. Most of your homework is about like this. Yeah. We're going to do some slightly more complicated ones because I want you to see them. But I don't think they're going to be this complicated they will be this complicated on the test and on the homework, but I don't think they were going to be as complicated as the one that I'm going to do now. I could be wrong. Part of the reason is because this one's going to have multiple fractions in its answer. So, sketch. F of x is 6x to the fourth minus x cubed minus 77x squared plus 86x minus 24. So we're going to fully factor using synthetic division. And this problem is probably going to take me 2 pages. So P over Q is going to be these numbers from the last thing divided by the numbers from the front thing. They're always going to be positive or negative. We don't know if it's positive or negative. It could be either. And we're going to start small. 1 is always a possibility. Sorry, I'm trying to decide where I want to start with this. Yeah, we'll start with 1. I'm going to do fractions, though, from here. So, because we could have 1 over the factors of this, we can get plus or minus 1 over 2, plus or minus 1 over 3, plus or minus 1 over 6. Those are all the factors of 6. 1, 2, 3, 6. Great. Now we just increase this to the next root of 24, which is going to be 2. So plus or minus 2 over 1, plus or minus 2 over 2, except this is just 1, so this one doesn't really count because it simplifies. Plus or minus 2 over 3, and then plus or minus 2 over 6. This simplifies to be the 1/3, so this one also we don't care about. Okay, so then we just keep going. Increase this 2 to a 3. There's going to be a lot of factors here. And we're not going to do all of them. I mean, we're not going to check all of them. We don't need to. But we're going to check some of them. So, sorry, we're increasing the top to 3 here. Yeah, so 3 over 1, plus or minus 3 over 2, plus or minus 3 over 3, which is 1, so we don't need that one, plus or minus 3 over 6, which is the same as the half, so we don't need that one either. Then we just increase the top of the fraction to the next factor of 24. So it's 1, 2, 3, and then you can divide 24 by 4. So 4 over 1 plus or minus 4 over 2. That's just 2, which is right here, plus or minus 4 over 3, plus or minus 4 over 6, which is 2/3, which is right here. So we don't need this 4/6. These can be tedious. We haven't actually even started factoring yet, but we just need all the possible factors. The next one's going to be 6. 4 and then 6. Plus or minus 6 over 1, plus or minus 6 over 2, plus or minus 6 over 3, plus or minus 6 over 6. This is 3, which we did already. This is 2, and this is 1. We've already done all those. This is the only one new one. The next factor is 8, plus or minus 8 over 1, plus or minus 8 over 2, 8 over 3 doesn't simplify, plus or minus 8 over 6. This 8 over 2 simplifies to be 4. 8 over 6 is going to be 4/3. We've done that one as well. 24 going to be divided by 8, 9, 10, 11, 12 is the next one. This is 6. So this is 6, this is 4, and this is 2, which we've already done. These won't always simplify so nicely, especially if these don't have similar factors. 6 and 24 have similar factors. But in this case they do. So 24 over 1, plus or minus 24 over 2, plus or minus 24 over 3, plus or minus 24 over 6. This is 24. This is 12, which we already did. This is 8, which is over here. And this is 4, which we did here. So lots of duplicates. We don't have to check those. We just have to check the ones we didn't cross out. So we're just going to start with 1, and then we're going to do a half. And we're checking with the synthetic division. So 1 into 6, -1, -77, 86, -24. And remember what we said when we were doing this rational root theorem stuff is if we're not getting 0 at the end, we don't need to do the whole synthetic division. This needs to equal 0. We only care about 1. Really, this would be, x minus 1 here. if we get 0 at the end of the synthetic division. I don't think we will. We'll see. So add down 6 times 1, 5 times 1, 72, negative 72 times 1. This is what, 14? 10? No. So we check negative 1. 6, negative 1, negative 77, 86, negative 24. Add down, multiply, negative 6, we get negative 7, multiply, we get positive 7, negative 70, 70. This is going to make a really big number. We're going to multiply it by a negative. We get a really big negative number. We don't get 0. I mean, I'll do it, but we're not going to get 0. 156, negative 156, negative 180. So it's not 1 or negative 1. So the next one on the list is a half. It's a fraction. So we're just going to do our synthetic division with the fraction. This can be written 2 ways. Well, never mind. So 6, negative 1, negative 77, 86, negative 24. So 6 times a half. 6 times a half is 3. Add down, we get 2 times a half is 1. We get 75. Negative 75. Nope, I'm sorry. Whoa. Negative 76. Half of that is 35, 36, 38. So negative 38. 86 minus negative 38 is going to be 48, I think. Times a half is 24. And so we get 0. So one of our solutions is a half. Now, here's the thing I want us to think about. Because we're dividing or multiplying by half here, we're dividing by 2 every time. So 6 divided by 2 is 3, right? 2 divided by 2 is 1. 76 divided by 2 is negative 38. If we ever get an odd number here that we have to multiply by half, we're probably not going to end up with 0. So that's just a thing to be looking out for. All right, so this 1/2 means that it could be x minus a half times 6x to the third plus 2x squared minus 76x plus 48. Now, this has a greatest common factor of 2. So what I'm going to do is multiply this 2 times everything here. I'm going to factor out a 2 out of all this and multiply it by this thing. I'm just going to move the 2. So we're factoring it out of this, x minus a half, times 2 times 3x cubed plus x squared minus 38x plus 24. And so this 2 can become 2x minus 1. This might be more clear, this x minus a half, what the root is. what the zero is, what the root is, what the solution is that it's 1/2, but we like the integers better. So really either one of these, but this is easier to work with. Now here's the thing. This 3x cubed plus x squared minus 38, that's a 38, you gotta be careful. X plus 24. This needs to be factored. It's not going to factor by grouping, and so we need to do the rational root theorem again, but just to this part. So we can use our list from before, but all of these that are now divided by 2 don't work anymore. We already factored out the 2, or the 1/2, and this, what is it, q here, the factors are 1 and 3 instead of 1, 2, 3, and 6 like they were at the beginning of the problem. And so we can ignore like a bunch of these, like 1/6 is not the solution. 1/3 could be for this new function. Okay. So we're going to do the rational root theorem again. But we're going to do it for 3x cubed plus x squared minus 38x plus 24. In other words, we're just going to factor this by guessing and checking using the synthetic division. And I'm going to continue to use the list that I had before, except I'm going to ignore the ones that don't have the factor of 3 as a possibility. Yeah, so we're going to check 1/3. We already checked 1. 1 wasn't an option. So it's not going to be an option now for this function. So we just start with 1/3. 3, 1, negative 38, 24. Add down, multiply by 1/3, we get 1. We add, we get 2. If we multiply here, we get 2/3. This is not going to magically go away when we add and subtract. We're going to get a weird mixed fraction, and this is not going to equal 0 at the end. It's not going to work. So we just check the next one. So to explain that more, I know this isn't going to work because when I add these, I'm going to get negative 37 and 1/3. And then I have to multiply this by 1/3, which means I'm going to get like something with ninths. And when I add it to 24, that's not going to give me 0. So a clue here is that when we add, if we're not getting integers down here that are divisible by 3, then that is not a solution. We should be getting only integers at the bottom. We're still using a fraction, but we should be simplifying to integers down here. Okay, so for negative 1/3, 3, 1, negative 38, 24, we get 3. Multiply here, we get negative 1, we get 0. Multiply, we get 0, we get negative 38. Is 38 divisible by 3? Not evenly. So this would be 38 over 3. That's not going to add to be 0, so it's not negative 1/3. Okay, so we checked 1, we checked a half, we checked a third. We're not going to check 1/6 because 1/2 worked, and now we're guessing and checking for this function here, this 3x cubed plus x squared minus 38x. This is not 6 anymore, and so 1/6 is not actually a possible factor. It is for this function, It didn't turn out to be. Like we would have, if we would have guessed 1/6, we would have checked both of those, it wouldn't have worked. But this new function down here that we got after we factored out 2x minus 1 doesn't have a 6 in front, so 1/6 is not one of the possible things. So the next number we check is going to be 2. 2 into 3, 1, negative 38, and 24. So here we add down, and then we multiply diagonally. 3 multiply 7, 14, 14 minus 38, oh man, 24, negative 24, times 2 gives me negative 48. This is negative 20, this is not 0, it's not 2. Check negative 2. Add down 3, negative 6, 5, negative 10, negative 48, times 2 is like 96, 120. So we're going to keep checking till we find one that equals 0, but it's not 2 and it's not a third. So the next number on the list, we check 2, is now 2/3. 2 over 3 into 3, 1, negative 38, 24. Add down. This gives us 3 times 2/3 is 2. Add, we get 3 times 2/3 is 2 again. Negative 36 times 2/3. I don't actually know. So 72 over 3, 24. But it's negative. So negative 24, and we get 0. So that means that not only can we factor out this 2x minus 1, we also factor out the x minus 2 over 3 times 3x squared plus 3x minus 36. And again, we have a greatest common factor here of 3. So we factor out a 3, we're going to multiply it by this thing to simplify that fraction. So we get 2x minus 1 times, I'll show all the steps, times 3 times x squared plus x minus 12. This turns into 3x minus 2, x squared plus x minus 12. Now we need to factor this part still to find the other two solutions. That I would use the Xbox method. So A is 1, B is 1, C is negative 12. Two numbers that multiply to make negative 12 and add to make 1. Remember, this is A, C, and B. If you need a refresher on the Xbox method, you have to go back in the YouTube videos and watch the quadratics factoring lessons. Two numbers that multiply to make 12, add to make 1 are going to be 3 and 4. The 3 is the negative one. Those just become part of our answer. X plus 4. So this is fully factored. And then we need the solutions. Now, just use the solutions you found from the synthetic division. You can set these equal to 0 and solve. Or just remember that we said, oh, 1/2 gave us 0 at the end. When we did all this synthetic division here, when we did 1/2, we got 0, so 1/2 is one of the solutions. And then when we did synthetic division to get this, we said it was 2/3, so x is 2/3. Here, x is going to be 3, and x equals -4. So those are my 4 solutions, my 4 coordinate points. So now I'm going to sketch them. So I have -4, I have +3, I have 1/2, just like there, and I have 2/3. These are really close together. Somewhere in there. Not to scale completely. Okay, my original function was 6x to the 4th minus x cubed minus 77x plus 86x minus 24. So my leading coefficient and my degree come from here. It's an even degree and it's positive. So I look on my chart at the even degree section. We want a positive leading coefficient. The ends are going to point up. Sorry, that was fast. So it's even degree and positive, so the ends are pointing up. As x goes to the right, the function gets bigger. As x goes to the left, the function still gets bigger. So it's going to go this way. None of these had a multiplicity. When we fully factored it, we got nothing squared still at the end. There's not like a 2 here. There wasn't an x that was a greatest common factor. So that means that when we draw through the points, it's going to pass through every time. So we're coming in from this way, goes through, it's going to go through, and go through. Now, this could go like way up. I actually don't know how high it gets in between these 2 points. And this could go like way down here. It could be way steeper. That'd be fine. The only thing we care about is the end behavior in the right direction? Does it pass through all the points correctly, or does it bounce if there's a multiplicity? Okay. So that's what we're doing. We're fully factoring. Sometimes it will take a long time. That one we checked a lot of things with synthetic division. We checked 1, 2, 3, 4, 5, 6, 7, 8. 8. Now, we found 2 solutions that way. You can always just keep doing the synthetic division. You don't have to do this Xbox method. You could just keep checking with synthetic division until you find all of them. Okay, and then our end product, the thing we're left with at the end, is a sketch. Okay. So this is what the homework is asking you to do. It wants a sketch at the end. You need to fully factor, find the roots, but then you also, the goal is to have the sketch at the end. On the test, on the Nearpod, we're going to ask you to do this. Part of the test is going to be a Nearpod, where you have to draw or sketch the graph. Okay. And then there might be some short answer stuff in the multiple choice, or like on the other assessment part, but part of it will be on Nearpod, where we want you to use your finger or mouse, however you want to do it, to draw. Okay. So that's how we fully factor and then sketch using end behavior, roots, and multiplicity.